Hey guys, we're going to do section 2.2, histograms, frequency polygons, and ogives. So we're going to be graphing today. Just so you know, it is 1 o'clock in the morning and I'm watching the longest raise game ever. Hopefully we win. We'll find out in a few minutes. Okay, the objective is to represent data in frequency distributions graphically. So we have 3 frequency distributions. Remember, we've talked about that. The three distributions being grouped, cumulative, and relative, and we worked on that in class. Today I'm going to teach you how to represent those graphically with histograms, frequency polygons, and ogives. There are also 2 types of histograms, just so you know. There's the regular histogram, and then there's one called relative. And that's dealing with the percent signs that come from your relative grouped frequency distribution. Okay. What you should have learned so far in Chapter 2. There are 3 types of frequency distributions. There's categorical, which is your qualitative data, so your words, not your numbers, your qualitative data. Your ungrouped, which has a small range, and the example that I did in class with you guys would be the age of the students in our class. And then our group data is going to have a large range. So that was the actresses that won the Academy Award. The oldest I think was 81, the youngest was 29, 20. And when you do the range of that, you get 61, which is a large range. What's getting confusing for you guys are the fact that there are 2 types of grouped frequencies. There's cumulative, which hopefully you guys have practiced and mastered, and then there's relative. I'm not going to read all of this because you guys can read it for yourself, but what the major part of it is saying the reason why we graph is to make it easier for people to comprehend the meaning of the data set graphically, and also to inform you again the 3 major types are histogram, frequency polygon, and the ogive. Alright, let's get started. Histogram and relative histogram. So here's your definition of histogram. You have a graph that displays the data by using contiguous or touching vertical bars of various heights to represent the frequencies of the classes. So let's look at this one right here. This is your grouped frequency table or grouped frequency distribution. Here are your classes, we've talked about those, and here are the frequencies. And again, these are the ages of the best actress. We keep using this example over and over. What you do to make a histogram, notice down here, what are those numbers? 20.5, 30.5, 40.5? Those are your boundaries. So the very first thing that we have to do is actually find the boundary of each class. And then over here are my frequencies, how high they're going up. So the class right here, 21 to 30, should be right at 28, and it is. The next one should be right at 30, and it is. So notice that we have the class boundaries down here and our vertical bars are touching. Over here, our relative histogram is almost identical to the regular histogram. The only thing that's going to be different is your y-axis is going to have the percents on them rather than the actual frequencies. How do we go from 28 to 37? How do we go from the 28 to 37? Remember, you do 28 divided by however many there are, which is 76. And how did I get 76? That was the total of all of my actresses. So 28 divided by 76, and then whatever you get with that, times that by 100, and that should be right around 37%. You have to do that for every frequency over here and change it to a relative frequency, which is a percent. You can always check yourself by adding this column up, and it should add to 100. Okay. Why do we use relative frequency graphs? Real fast, the book will use the word proportions from now until the end of the year. And whenever they say proportions, I want you to think of percents. When you say percents, you need to think of relative frequency graphs. So, graphs use relative frequencies instead of frequencies when the proportion of data that falls into a given class, remember when I say proportion, what are you going to think? You're going to think percents. So when the percent of data that falls into a class is more important than the actual number. What do I mean by actual number? Well, that's this guy right here. That's the actual number. So what's more important than the actual number is the percents, and here's an example of why. Let's compare the most populous state, which is Texas, to the least populous state, which is Wyoming. There's a total of, I think, 25.3 million people in Texas versus 544,000 people in Wyoming. So if I were to tell you the amount of people, children that are 18 and under, for Texas you've got 7.3 million, and for Wyoming we have 144,000. So right now, my word, it seems like Texas is way more populated with kids under the age of 12 or under the age of 18. But in actual reality, it is only 29% of children 18 and under versus 26%. This is the reason why graphs will use relative frequencies, which represent percents, instead of the actual numbers. So this is the reason why. Let's go ahead and let's do an example. So example 1A, how to make a histogram, a regular histogram of the record high temps. So this is the actual grouped frequency that you made several days ago. So here are our steps to making a histogram. Make a group frequency distribution. Well, we did that. Find the class boundaries. We need to go and we need to find those numbers before and after each little part. So I'm going to go ahead and do that now, so you can go pause the video and then do it on your own and then come and check it. Don't just wait for me to do it. Actually go and see if you can find the correct boundaries. So the first one that's extremely important is your lower boundary, 99.5, and then all you have to do for the rest of them are to include your 0.5 on all of these, because once you have your lower one, all the rest of them are going to be just the upper limit made into a boundary, and we just simply do that by adding 0.5. So now we've done find the class boundaries. Now it says to draw and label the x and y axis. So here we have our y-axis, here's our x-axis. We're going to label the x-axis with our class boundaries, which would be temperature, and then our y-axis is going to be frequency. Check. Represent the frequency on the y-axis and the class boundaries on the x-axis. So what I'm going to do, I'm going to have 1, 2, 3, 4, 5, 6, 7, 8 little tick marks. Make it nice and even. 1, 2, 3, 4, 5, 6, 7, 8. That was pretty good if I do say so myself. And then I'm going to go and I'm going to put 99.5 here, 104.5 here, 109.5, 114.5, 119.5, 124.5, 129.5, and the last one, 134.5. Sorry, that's messy. And then now you need to look at your frequencies and notice how high your frequencies go. Our lowest is 2 and our highest is 18. So I'm going to go by 2s along this actual y-axis right here. 0 starts right here, 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I might not write all of them down, but I know I did. My tick marks are by 2s. Now what you're going to do, I've represented the frequency on the y-axis and the class boundaries on the x-axis. Now I'm going to use my frequencies as the heights and draw vertical bars. Remember, your vertical bars need to be touching. So I'm going to go here and I'm going to actually draw in my vertical bars. So for this first class, I need to go to a height of 2, which is right here. My second class, I go up here and I look and it's 8, so I'm going up to 8. And drawing my vertical bar. My third class is 18, so I'm starting from here, going all the way up to 18, drawing my vertical bar. My next one is 13, so it's halfway in between. And then I've got 7, and then I've got 1, and then 1. And that is a histogram. Now let's do a relative histogram. Remember, your relative histogram is going to have the same everything except for your frequency. We need to change it to a relative frequency. So I'm going to go ahead and draw in the boundaries on the left, and then I'll walk with you making those frequencies into relative frequencies. Okay, there are my class boundaries. So I made a grouped frequency distribution. I found the class boundaries. Now I'm going to convert the frequencies to percents by dividing the frequency, that's each of these are all called my frequency for the classes, by the total, which if I added all those up, I got 50, and I'm going to then multiply that number by 100. So I'm going to take 2, put it over 50, and then when I get that, when I do 2 divided by 50, I get 0.04. I'm going to take that and multiply it by 100, and I'm going to get 4%. So I'm going to do that for every single one of them. If you need to, pause the video, you go try it yourself and see if you get the same numbers that I do. Okay, so hopefully you did that on your own and you're checking the work. Again, remember we did 2 divided by 50, 8 divided by 50, 18 divided by 50, and then we have to multiply those problems by 100. And then now what you want to do, just to double check yourself and make sure you're doing it right, add this whole entire column up, and what should it add up to? 100%. Looks funny. Okay, so now we've converted them all to frequencies. We converted all our frequencies to percents. Now I'm going to draw and label my x and y axis. Here's my y, here's my x, and then I'm going to represent the relative frequencies on the y axis. So I would title this relative frequency. I'm running out of space here. And then on down here is still going to be temperature. So I've represented that. Now I just need to use my relative frequencies as the heights and draw vertical bars. So I need to go through and do my class boundaries again. So I'm going to have 8 tick marks down here. Try to have them the same space all throughout the whole thing. I'm going to go and put my class boundaries down here. Now that I've done all of those, that last one is supposed to be 134.5. I'm going to go and do my relative frequency. Now I need to go and check what my actual y-axis, check my frequencies. My highest is 36, my lowest is 2. So I'm going to go from 0 to probably 36, and I'll probably go by 4s. So 0, 4, 8, 12, 16, 20, 24, 28, 30, 32, 36. Okay, apparently I made a mistake and made too many. So now what we're going to do is we're going to use the relative frequency as our heights, and we're going to draw vertical bars for each class. Remember, these need to be touching. So for my first class, I look up here, it's 4%, so that's going to be my first bar. And then my next class is 16%, so I'm going to go ahead and do this up to 16. The class after that is 36%, so I'm going all the way up to 36, all the way back down, and then I'm doing 26% for the next class. And then after that is 14%. And then after that I'm back at 2, and then back at 2 again. That really wasn't 2. That was a bad 2. 2 should have been right there. That is how you make a relative histogram. Next, we have a frequency polygon. This is a graph that displays the data by using lines that connect points plotted for the frequencies. So we're still dealing with frequencies at the midpoints. This is the one that you're going to need to find midpoints for each of the classes. The frequencies are represented by the heights of the points. So here, notice we have the same table, but now we have the midpoints, and we still have the frequencies. We didn't do anything to the right side whatsoever. The hard part for kids to do is this part right here, the beginning and the end. Notice our very first midpoint is 25.5, and it's away. It's a little bit away from the corner. So here is 25.5. We had right around 28, but our line is going to extend down, and that's the part a lot of kids forget, is this part right here. And just like the last one, for 75.5, we have our data value of 2. So that's technically our last one, but we have to make sure we always connect the graph back to the x-axis. So let's do an example. Example 2, make a frequency polygon of record high temps. Here are my steps on how to do it, and here's my table. Now again, this is the same temperature table we keep dealing with. The very first thing is to make a grouped frequency distribution. Well, we've done that. Second thing, find the midpoints. How do I find the midpoints? You add the upper and lower limit and divide by 2. So 100 plus 104 divided by 2. You only have to do that one time. Because remember, once you know what the class is, the class width is from here to here, it's 5, I can just add the class width the whole way down. And that way I don't have to sit there and figure it out each time. Alright, next thing, draw and label the x and the y axis. So we're doing that again. Label the x-axis with the midpoints and then use a suitable scale on the y-axis. So right now for the x-axis is what I'm focusing on. I have 1, 2, 3, 4, 5, 6, 7 midpoints. Remember, set it a little bit away. So 1, 2, 3, 4, 5, 6, 7. And I'm going to add a little bit of distance right here so it could be nice and pretty at the ends. And then I'm going to use a suitable scale for the y-axis. So here I have my lowest is 1, my highest is 18, so again I'll go by 2s. 0, 2, 4, 6, 8, 10, 12, 14, 16, 18. 18, 14, 10, 6, 2, and then 0 at the very bottom. I should have done it the other way, but it's okay. I'm going to go ahead and put my midpoints here. 102, 107, 112, 117, 122, 127, and 132. That should be labeled temperatures, and this should be labeled frequency. And then all you're going to do is plot the points. So for 102, we're at 2, so we're going right here. And the next one, 107 and 8, 112, 18, 117, and then 13. 122 is 7. 127 is 1. And then the next one's 1. And then now what I'm going to do is I'm going to connect those with line segments. So from here to here, from here to here, from here to here, all the way. And then don't forget, at the very end, that's what I have right here, at the beginning and end of the graph, you need to make sure you're connecting it the same distance. So don't go straight down. That's not what you're going to want to do. So what you're going to actually want to do is just connect it probably about the same distance that you have in between each one. Same thing over here. I'm about this far away, so I'm going to go down. And that would be called a frequency polygon. That's it. Done. The next and the last one we're going to talk about is something called an ogive. And the ogive you're not going to like. And the reason why you're not going to like an ogive, because the very first step is to make a cumulative frequency distribution. To make a cumulative frequency distribution, you need to actually make a frequency distribution first and then change it to cumulative. How do we change it to cumulative? Remember, that's when we have the less than signs in there, and then we have it with the actual upper boundaries. Remember, very important, start at 0, and this is the reason why your graph needs to start at 0 and then work its way up. The thing with an ogive is that it should always be going up, because what are our numbers doing down here? They're always going up. And then the very last number is going to always be the last number, or the number of values in your data set. So let's go ahead and do an example. Let's make an ogive of the record high temps. So here is our grouped frequency distribution. This is our grouped one, and that's our first step. We've already done that. Then we need to make a cumulative. So remember, with cumulative, you need to first do your less than signs, which are right here. And then the hardest one to remember is that you've got to do the lower limit between or before this guy. So before 100 is 99.5. You need to make sure you include this one. And this one's very important. I know you guys are going to forget that one. And then as soon as you do 99.5, you can just simply add whatever the class width. As you can see, our class width from here is 5. That's how far apart the classes are. So you could just add 5 all the way down. When you're doing your cumulative frequency, remember to accumulate as you're going. And so what I was showing kids in class is to actually read this and understand what it means. How many data values do we have less than 99.5? Well, 99.5 is right here. And we have absolutely no data values below there, so that's why it's 0. Now let's go to 104.5. Well, 104.5 is right here. Less than that would be this class, and that's why we have 2. And then after that is less than 109.5. Well, 109.5 falls here, and it says less than it, so that would be both of those classes, which means we're going to add these two numbers, and that's where 10 comes from. And then lastly, we have, well, not lastly, definitely not lastly, we have less than 114.5. So that would be here, and that's going to be less than, so it's all 3 of these classes. So hopefully by now you've gotten cumulative frequency distribution. So check, we've got that checked off. Now we're going to draw the x and the y-axis, which is what we've been doing. And then label the x-axis with the class boundaries. We've done that before. So here's my temperature down here. I'm going to go through, and I've got 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to put my class boundaries here. And then it says on the y-axis for the frequencies, my highest is 50. So I'm going from 0 to 50. So I'm going to go by 5s. 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Zero. And then I'm going to put my class boundaries down here. Now that I've done that, I'm going to go and I'm going to plot my points. So for the first class, I have 0. That's my starting point. My next one, I'm at 2, and then I'm at 10, and then I'm at 28, and then the next one is 41, 48, 49, and then the last one is 50. So notice again that what are my dots doing? They are definitely increasing, and that is the whole point. You should always be increasing as you're going up an ogive. Alright, and that would be it. You don't have to bring it back down. You can leave it just sitting up there in the air. Okay, let's talk about the distribution of shapes. We have this thing called peaks. You learned about it on page 45, 1 through 7, and it basically means you have data values that fall on either side of it and then taper off. So here are our major shapes that we're going to be talking about this school year. Bell-shaped has a single peak. It tapers off at the end. It looks something along the lines of that. A uniform-shaped is basically flat and rectangular. Right-skewed has a peak to the left and then a tail to the right. So it looks kind of like this. Left-skewed has a peak on the right and a tail on the left. Looks like that. Unimodal can have one peak anywhere. And then bimodal could have 2 peaks, and then U-shaped actually forms the shape of a U. So those are all of your basic shapes of a graph. When it comes to analyzing histograms, which is what you're going to be doing, remember histograms are your vertical bar ones. Oh, they're supposed to be touching. So vertical bars like this. So when it comes to analyzing them, here are some questions that you might want to ask yourself. Does it have one peak? If it has one peak, it would be unimodal. If it has 2 peaks, it would be called bimodal. Where does the peak occur? At what class? Because you want to be able to notify them or tell them that. Is it relatively flat, meaning uniform, so a graph that looks like this? Or is it U-shaped, kind of going up and down like that? Are the data values spread out? Again, uniform. Or are they clustered around the center, which would be bell-shaped? Something like that. Are the data values in the extreme ends right or left skewed? Are there any gaps in the histogram? And what I mean by gaps are all of a sudden if you have all of these peaks, all of these, not peaks, but all of these vertical bars, and then you have absolutely nothing, no vertical bar, and then it shoots back up again. That's considered a gap. And now what I want you to do is I want you to look at the histogram for the record high temps and then comment on its distribution. So go back to our very first example where we had our histogram, and then I want you to comment on its distribution. Is it relatively flat? Where does the peak occur? How many peaks are there? Are there extreme ends? Is it bell-shaped? These are all the questions that you should be thinking about when you go to make comments on its distribution. Go ahead and pause because I'm going to put the answer up in a few minutes. Okay, so I've actually brought in the histogram. This is the histogram that we did a couple slides ago. So we're going to look at it. We're going to comment on its distribution. Hopefully you've gone through and made some actual comments. It is definitely unimodal. You can tell by this guy right here. So we could say it's unimodal. Note where it's unimodal at. Where is the peak actually occurring? And so it's occurring in the class 109.5 to 114.5. And then also talk about how there are no gaps. We don't ever really hit the x-axis. I have a quantity at every single one. I know that you might be thinking that it's actually bell-shaped, but bell-shaped would be a little bit more to this part. You would have a little bit more in the middle. It's a little bit more to the left, which you could call it right skewed, but it's not necessarily there because you still have this one that's causing it really not to be. If these two were switched, then yes, you could say it's right skewed, but it's not. Okay, that's it. I hope it wasn't too long for you guys, and the game is still on. It is now almost 2 o'clock in the morning, and I feel bad for the baseball players. They're probably so tired right now.